Turns out that that's where I have the highest concentration of cones. If every dot that I make represents an individual cone, there's no gaps between the cones. That means I don't miss anything. I see the greatest amount of detail there. As I go further out from the fovea, the cones are spread out a little bit more, and the further out I go, the more spread out the cones become. And when I get all the way out here to the edge, they're fewer and further between. So when we describe the fovea, we describe it this way. It is a location on the retina in the center of our visual field that has the highest, that's my abbreviation for highest, an up arrow with S, highest concentration of photoreceptors, and it's cones only. And that is where we have our sharpest vision. You can do this quick experiment with me. If you take your two pinkies and hold them up and you're staring at your fingerprints, put them at a distance where you can read your fingerprints. Leave your left pinky there and stare at it and move your right pinky over some distance. The left pinky, you will see every detail. The right pinky will be blurry and missing information. And the reason is your left pinky, all of the photons are landing right here and we're not missing a single point of light. But the other pinky, which might be here, would be coming in at an angle, and some of those photons would be missing photoreceptors because the photoreceptors are spread out. So we can't see those photons of light. We're missing detail in our peripheral vision. That's why when we want to see the greatest amount of detail, we turn our head and look at something. If you hear a loud noise, you turn and look at it so that you can identify exactly what it is. So that's what the fovea is. It's a spot on the retina in the center of our visual field that has the highest concentration of photoreceptors and cones only. It's where we see the greatest amount of detail. That's why we turn our eyes toward an object to see the detail. Turns out the rods are actually in reverse. There are no rods in the fovea. The rods are in a higher concentration out in the periphery, and the closer we get to the center of the eye, the fewer and further between the rods become. That's why in the dark, our peripheral vision is better than our central vision. That's why we can see images and outlines, but we can't see detail. All right? So anyway, a couple of things I want you to know about this. The fovea is where we have cones only. We see the greatest detail. If I were to destroy the fovea, by the way, you would not go blind, and you would not lose the ability to see color because I still have cones in the eye, but I would lose the ability to see great detail. So in macular degeneration, where the fovea and the macula are dying, patients lose the ability to see great detail and blindness starts setting in. They can still see color, they can still see some, but the loss of sharp vision occurs. So now, I hope that helps you understand sort of how the retina is set up, what retinal organization is, and the major functions of the retina, how photoreceptors are set up in the retina, and all of that. Anyway, I believe that covers all the visual physiology that I want to cover. There are some sections in your lecture textbook, as I flip through the note set. I'm not going to do all of page 17. You can do the steps of visual physiology if you like. You should also read about stereo vision. You should read about day and night vision. You should read all the details in the lecture text, but the test questions that I'm going to cover are going to come from the lectures that I've done up to now. So we're done with vision. I hope you learned something. I hope you had as much fun as I did. And I hope to see you in the next few lectures where we're going to cover equilibrium and hearing. Thanks for watching.